Hi, welcome to ProGreen Design Limited.
ProGreen is an innovative design consultancy based on bringing affordable and environmental design solutions to major integrated system projects. The team's core comprise of project management, producing innovative design solutions, and strategic implementation. The team is spearheaded by our project manager, Jake Hobbs. The design team is made up of two experienced and creative members, our executive designer, Greg Palmer, and our computer-aided design specialist, Yu Lei. Finally, there's our human resource manager and secretary, Joe Martin. Together, ProGreen makes an integrated and experienced team. So now let's take you through one of our current projects. Quoit Farm is an eco-village comprising a major integrated system project. It contains 410 affordable eco-homes, supported by a detailed design of a leisure centre complex. A school and playing field for the village and local needs is also provided. Shops and restaurants comprise the central hub of the village, providing all amenities, with waste and water treated and recycled on site. Finally, the village is powered by renewable energy sources, solar PV and biomass district heating. Together these deliverables comprise the design of an integrated eco-village. The location selected was Quoit Farm, a 450,000 metre squared site just outside of Newquay, Cornwall. There is a strong demand for housing within the area, and the site has previously been highlighted by Cornwall Council for the potential development of an eco-village. There are excellent transport links, less than 1 mile to the A39, 5 miles to the airport and 7 from Newquay itself. The south-facing site with a gentle 1 in 20 slope also optimises potential solar gain. So let's take you through the site. The site is situated in close proximity to the main link road throughout Devon and Cornwall and sits adjacent to the A389, providing excellent transport links to the surrounding areas. The village itself consists of 410 affordable houses that are to be built to level 4 of the 2016 Code for Sustainable Homes, with the aim to reduce energy consumption and become carbon neutral. This is being carried out by focusing on materials with low environmental impacts. There are 4 different types of housing. There will be 76 2-bed houses, 134 3-bed houses, 138 4-bed houses and 66 5-bed houses. Based on statistics of the local area, the houses will be built and focus around young families. There are 5 shops and a pub situated within the central hub of the village. This will act as a focal point of the site where community gatherings and events such as fetes can occur within the surrounding green areas. There is a network of roads which make up the main transport system within the village. There is also an intricate network of secondary roads which interlink the houses within the village. These are to be produced using an eco-paved road surface which is comprised of local soil which when constructed holds equal strength to concrete. A leisure centre is situated along the south side of the village. This comprised the group's main design deliverable within the project and consisted of a multi-court sports hall, a swimming pool, a gym and a dance studio. A multi-weather AstroTurf pitch is also located adjacent to the leisure centre building, which can accommodate for various sports such as football and hockey. The village will also include a primary school which will hold a capacity of 300 pupils. This will allow for children living within the village, along with the children from surrounding areas, to attend the school. It was decided that the school was to be located adjacent to the leisure centre to enable pupils to use the leisure centre facilities for PE classes and after-school activities. A biomatrix multi-stage recirculating wetland treatment system will be used to provide recycled water for use within the village due to its excellent environmental performance figures and aesthetic appeal. to promote eco and environmental living, the village incorporates large open green spaces for community gatherings and for young children to play. Green space between houses also promotes sub-communities to form. The village will be powered by the use of PV solar panels, which will be situated within an adjacent site to the village, separated by a small country road. A total of 75,000 solar panels will provide more than enough electricity to power the entire village. A biomass centre will be used to generate the heating for the village. The uses of wood pellets to heat the biomass centre are around 50% cheaper than traditional heating systems, therefore providing a cheaper and more environmentally friendly system. The houses are built to level 4 of the 2016 Code for Sustainable Homes. In order to reduce construction cost and time, the houses are based on interchangeable modules, with 2 and 3 bed houses one module and 4 and 5 bed houses as another, as shown. In line with the 2016 Code, energy and carbon emissions are offset, with power coming from the solar farm and heat from the biomass district centre. Waste is also monitored and reduced through construction in modules in line with the 2016 Code. Sustainable materials are timber frame and zinc and sedum roofing, as well as those to improve thermal mass. Clay bricks and double glazing are used throughout. As can be seen, the health and well-being of residents is ensured through aesthetic design as well as views throughout the village. Detailed designs have been produced for the leisure centre complex, taking into account structural calculations, integrated systems and subsequent design standards. The leisure centre has been designed to contain a 25-metre swimming pool, gym facilities, dance studios, sports hall, necessary changing facilities and cafe. Adjacent to the leisure centre, there will also be an AstroTurf, football and hockey pitch. Within the leisure centre, a series of integrated systems have been considered, including fire, security, lighting and heating, ventilation and air conditioning. The cost of this is £5.2 million. The leisure centre will be constructed using locally sourced materials. The strength and structure is provided by a steel frame, with walls consisting of clay brick and autoclaved aerated concrete to give the building a good thermal mass. The roof will use zinc as its construction material due to its good thermal mass and sustainable properties. The structural design to the building has been completed using the relevant Euro. All the systems within the leisure centre will be integrated together as part of a building management system that have been designed to the British standards. This will have control over all the systems and ensure they can work efficiently together. The security system has been designed to be as low-key as possible, with access control, CCTV and intruder control systems integrated within the building. The heating, ventilation and air conditioning system consists of a biomass boiler which will cope with the heating demand, domestic hot water and the heating in the swimming pool. An absorption refrigerator chiller package has also been implemented as part of the air conditioning system. Here our Gantt chart can be seen over the whole timescale of the project. It shows first the planning stage, which are needed before any construction starts. These include planning permission applications, feasible studies and the purchase of the site. The second stage is the construction of the key deliverables. And finally, the installation stage of the build. These activities can start before construction has been finished to save time and costs. The schedule shows that residents could have the potential to move to site after 39 months. Throughout the project, there are several risks that have been identified which could prevent the success of the project. The Prince2 methodology has been adopted to identify and mitigate the risks that may occur. Risks identified have been compiled in the detailed risk register shown here. The register allows us to assess and quantify the probability and impact of the threat by assuring an initial risk score. Steps are then taken to mitigate these risks and a residual risk score can be seen. This has been simplified within this table to show risk types and how these can affect the project, as well as how we've implemented processes to mitigate the risk. The village design meets stakeholders' needs and wants. The local government has set the target to build 3,300 houses within the area, of which the eco-village provides 410. The national government needs are met through the affordable housing scheme, which will be constructed to target level 4 in the Code for Sustainable Homes, in line with the government target for zero carbon builds. Local businesses have been selected as suppliers in order to cut transport costs and also to help the local community economically by generating jobs. Investors' needs are also met, as the Eco-Village project provides a healthy profit within 4 years. Local residents and landowners will be provided with facilities such as the leisure centre. A SWOT analysis was undertaken which allowed the team to optimise its strengths, such as excellent team cohesion and detailed management skills, whilst paying special attention to company weaknesses by implementing training tasks to improve the team's collaborative skill set. Opportunities such as international expansion are also at the forefront of the company's future. Mitigation actions have been employed to reduce potential threats such as competition from similar companies. A lean thinking approach has been introduced to improve efficiency and to reduce company costs. ProGreen has produced a detailed financial breakdown of the major costs. The largest cost is the affordable housing scheme, costing £20.2 million. The leisure centre complex will cost £5.2 million for construction and installation of various facilities within. The school and playing field will cost £1.53 million. The solar farm will cost £3.02 million for the installation of PV panels and connection to the system. The biomass heating will cost £3.2 million for plant construction and connection to the district heating network. The central hub of the village, including shop, shelves and restaurant, will cost £500,000. And finally, the innovative biomatrix water and waste treatment facility will cost £120,000. The total cost for construction of the village therefore totals £34 million. ProGreen have produced a full discounted flow analysis with initial capital assumed at £13 million from funded stakeholders and a further £14 million from a deposit at the sale of first 100 houses. The analysis shows a potential net profit per annum of £1.8 million, internal rate of return on gross profit at 23% and return on net profit at 18%. This results in a payback time of just 4 years. We believe we're in a position to go ahead and implement our designs. We have the organisation, technical skills and passion behind the project. We believe Quoit Farm Eco-Village meets the needs of all stakeholders. At ProGreen, we hope you can see what a brilliant investment opportunity this project has, and with your help, we hope to make a ProGreen future.